I'm a professor at the University of Wisconsin in Madison. I work at the Center for Limnology. I'm a limnologist. I study lakes. I'm especially interested in water quality. Also enjoy spending time on the water. And my research program focuses on thinking about long-term change in lakes and rivers. And I've been doing a lot of research in the last decade on monitoring freshwater salinization. So this problem that we have with excess salts going into our lakes and rivers, I think about what that means for ecosystems and then the sort of downstream impacts on both ecosystems and human health. And this is a interesting week to be talking to you all about salt, given the weather that we've had here locally in Madison, Wisconsin. There's been a lot of community discussion in the last week about how our roads are being cleared. And one interesting headline that I saw this week was a letter to the editor about how Madison prioritizes lake water quality over people's lives. And I would like to say for the record that we are trying to think about water quality for people's lives. Freshwater quality is incredibly important, especially when it comes to things like drinking water. So thinking about salt and trends, the place to start is thinking about how much salt we sort of use as a country. This is an infographic of the total amount of salt that's been used in the United States since the mid-1970s. And you can see that that number has sort of gone up over time. The light blue bar is the total amount of salt, and that darker blue bar is how much of that salt we're using just for roads. So you can see that in the 2020s, as a country, we're using about 20 million tons of salt a year. It's sort of amazing to think about that. Like, of all of the salt that's consumed in this country, half of it's being used for roads. About half is also being used sort of in the chemical industry. And a lot of other ways we use salt are quite minor for the overall total. So we use about 20 million tons a year. That salt is purchased, it's transported to a location, it's put on roads, and then it goes into the environment. So that's either into soils, into nearby lakes or rivers, sometimes straight into the ocean. And another interesting infographic was just to think about how much salt that is. There was an article about Minnesota earlier this year, thinking about how much salt Minnesota uses in a year. And they compared how big a pile of salt would be that is 500,000 tons, which is what Minnesota uses. And it would be about the size of the US Bank Stadium, so the NFL stadium. So you can sort of visualize that this is just how big Minnesota's salt pile is, and the US salt pile would be about 40 times this big. And that salt use is trending up, right? That graph is still increasing through time. And that's a result of just more urban land use. There's constantly new land development. This is a graph or a map from the Washington Post looking at percent increase in developed land. And you can see all over this country, there's increasing land development. For instance, I live in Madison, Wisconsin, and you can see that in the last 20 years, there's been sort of significant development in these kind of suburban areas. And as we get new urban development, we get more roads, we get more expectations that those roads are kept clear in the winter. And so even if we are decreasing the amount of salt we use per lane mile, if our lane miles are going up, the total salt use might also be going up. And the concern about this is that, as we have more lane miles, as we use more road salt, that's going to end up in the environment. So this is a map of the county salt use in Wisconsin. And if you know anything about the geography of Wisconsin, there's more people in the south, especially in the Madison and Milwaukee areas. And so there's more roads. And our fear is that the amount of salt running off into our freshwater ecosystems is going to create problems for organisms, problems for drinking water. These are the water quality guidelines for freshwater ecosystems in the US and Canada. And I bring these up because it's important to sort of have a sense of, what level of pollution we're talking about. And so the US EPA's chronic criteria of chloride toxicity is 230 milligrams per liter. And so that's a great number to keep in mind when thinking about, how much have we polluted some of these systems. And in a lot of these areas, states like Wisconsin, the natural chloride levels are incredibly low. There's just not a lot of chloride naturally found in the bedrock. It's not going to weather and be washed into these systems. And so historically, before humans started putting salt into the environment, the concentrations in many of our lakes and rivers were, less than 10 milligrams per liter, sometimes close to zero. So the result is what we see is that these maps of salt use correlate really strongly with maps of salinity in freshwater lakes and rivers. So the map on the left is the amount of road salt use in Wisconsin per county. The map in the middle is the chloride concentrations in rivers and lakes. And the map on the right is the sodium concentrations in public water systems, so drinking water systems. And the salt that we're putting on the roads is mostly sodium chloride. So that breaks down into sodium and chloride ions. And so if we measure sodium or chloride, it's a good tracker for human salt pollution. And so these maps, we don't have a lot of time to kind of stare at them, but what they're showing is that there's these hotspots, in the southeast around the Milwaukee area, and south central around Madison, up around Green Bay, and around these sort of major cities where a lot of salt use translates to salt problems in our waterways. And this is not just a Wisconsin problem. I just happen to have a lot of data from Wisconsin because I live here. But we certainly see the same thing in Minnesota. So lots of salt pollution around the Twin Cities area. We see the same thing in Michigan, lots of salt pollution around the Detroit area. And in more rural areas, like the UP of Michigan, northern Wisconsin, northern Minnesota, we really don't have any problems. There's just, not a lot of infrastructure where we get a lot of salt washing into the environment. That said, there are still issues. There are places that are right beside major highways that are influenced, but the problem's at a much sort of different scale. So where are we headed? What can we say about what might be happening to lakes and rivers at sort of a large scale? So there's two sort of main ways that lakes and rivers sort of show salinity problems. One is sort of this slow and steady increase, where if we just look at salt over time, it's kind of going up. And that tends to be seen in sort of larger lakes and groundwater. And then we also see this sort of episodic salinization signature, where we have a system that just gets really high salt in the winter and then it kind of clears up in the summer. And so we see that in smaller streams and rivers. And both of these are a problem in different ways. One is sort of more of a shock. You're getting a lot of salt at one time of the year. And the other one is sort of this just sort of this background creeping up of salinity. So we can start with the first one, and we see this signature in lakes, the sort of long-term increase. So this is data from lakes in Madison, Wisconsin, 3 lakes over the last 80 years, showing this steady increase in salinity. And one of the big questions that we all have is sort of, where is this headed? And the thing about salt is that it's a problem we can solve. If we stop putting salt in, it's going to naturally flush downstream, which is very different than other aquatic pollutants. So we can model this in a simple way if we know how much salt's coming into the system, how much is leaving every year, sort of what the trajectories are, what sort of like the final concentration should be if we assume some kind of steady state input. And so we can ask that. We can say, if we took all the lakes in the country, where is lake salinity heading? Are these lakes going to surpass these critical thresholds of 120 milligrams per liter or 230? And if we go back to the data from Madison, we can see that these lakes are kind of hitting the 100 milligram per liter. So they're still below that EPA toxicity threshold. But the question is, are they going to keep going? Are they going to hit that eventually, or will they level off? So we did that. I myself, along with some colleagues, did a modeling study where we were just focused on the Great Lakes watershed, but we looked at all the lakes in the Great Lakes region, and modeled their salt concentrations based on their watershed. So how many roads are in their watershed? How big is the lake? How quickly does it flush out? We can make some pretty educated guesses on what their concentration of salt is going to be in these lakes. And this is the results for the Great Lakes watershed. We can do this for the whole country, but this sort of simplifies things a little bit to look at just the Great Lakes region. It alone has 30,000 lakes. And you can see that there's sort of this spread of kind of these dark blue dots that are really low concentrations. So lakes that we would say have no human influence, versus the sort of orange and red dots where we have a lot of salt pollution coming from road salt. And again, this map sort of just mimics urban development for that obvious link with roads and road salt input. And we can look at this as sort of a more zoomed in scale. This is just the mitten of Michigan. And we can see that there is spatial variation, but I think the good news overall is that most of the lakes are kind of these blue dots, so relatively low concentrations. So the take home from this is that there's only a small percentage of lakes that are truly getting a lot of salt. The bad news is there's a lot of lakes that are getting a lot of salt. And if we look at this sort of just in total, our model suggested that there was maybe 3,000 lakes in this US side of the Great Lakes watershed that would hit 120 milligrams per liter, and less than 1,000 that would surpass that EPA threshold of 230. So that's, good news is a lot of lakes are just protected based on where they are. But there's still a lot of lakes that are at risk. But these tools do help in terms of management of being able to sort of pinpoint locations that are at risk and locations that might need more monitoring. So that was the result of the study of, how many lakes are getting salty. So one thing to keep in mind is that there's many reasons to be critical of these ecotoxicity thresholds. And we have a whole week of salt awareness talks, and I'm sure this will be talked about later in the week. But thinking about 230 is a single number based on lab tests of 3 organisms, and there's reasons to be critical of that, and systems might be at risk for different problems at concentrations lower than 230. So keeping in mind that these ecotoxicity thresholds should be questioned. And that these types of models can be used for management and restoration of systems. So moving on to quickly talk about rivers, thinking about rivers, one thing that's nice is that the United States Geological Survey has a series of river gauges across the country. They do a lot of water monitoring. There's over 10,000 river gauges that measure stream flow. And there's a subset of those gauges that measure specific conductance, which is a measure of how well water can conduct electricity, which measures basically just how much salt is dissolved in the water. So the higher the conductance of the water, that more ions are in the water. And this is a map of USGS gauges in the United States that have been measuring specific conductance for at least the last 5 years. And it looks like there's a lot of dots in this map. There's 700 sites. But if you think about just the vast amount of rivers and streams that are in this country, it's actually a very small number. And you can see that some states have none. Iowa has 0, and Minnesota has 4. So these numbers actually start getting quite small when you look at the scale of single states. So it might appear at first that we have a lot of data. I'm here to say that it would be nice to have more data. So if we think about rivers and streams, they can kind of be affected by both of these processes. One is this sort of slow and steady increase in salinity, and 2 is this sort of episodic salinization. And this is data from 2 different gauges. One is a river in Massachusetts on the top left. One is a river in Detroit, Michigan on the bottom left. And we can see that these are sort of these archetypal episodic salinity pulses where we get these big increases in conductance in the winter. So that's day of the year from zero being January 1st through March, and then pretty low concentrations in the summer, and then really high concentrations again, in December when we start salting the roads again. And so these can be problematic if you're an organism that's adapted to fresh water. You get these incredibly high spikes in the winter that you may or may not be able to survive. And then all of that salt is flushed downstream. And so it's that pollution is just being transferred from one location downstream to the next. So keeping in mind that all of these rivers are connected and these water monitoring sites are really just monitoring one location. So this is an example of that river in Detroit, Michigan on the bottom right, showing the river and just getting snapshots of that one location. And so thinking about what's happening in rivers, you both get this sort of pulse in the winter, but it's also important to look at what's happening in the summer, because it might seem low, but it might be changing over time. And so if we took these two river sites and looked at just what's happening in the summer, we can see that in some sites, the summer concentrations are actually increasing. And it seems like the one in Massachusetts might be, whereas the summer concentrations at the site in Detroit maybe are a little bit more stable. And so that trend of increasing summer concentrations is a concern, because that might be indicative of salinization of shallow groundwater. A lot of rivers are fed by groundwater in the summer. And so this is a way of teasing out sort of what's happening in groundwater over time. Whereas we can also tell what's happening in groundwater over time by actually measuring groundwater concentrations in groundwater wells. So again, just data from here in Madison, but showing that we also have sites where salinity is increasing in groundwater wells. And I think we know even less about this than we do rivers, just because there's so few monitoring sites. And I want to end just by kind of talking about the complexity of watersheds by focusing on this great USGS study that came out this year, looking at the Delaware River watershed. So this is a map of the Delaware River watershed and a bunch of monitoring sites. And this is a watershed that's really well monitored, much better than most watersheds in the United States. And so they were able to look at a lot of different trends. And I think this showcases the complexity, which is you have both scale, you have small streams in the north going into bigger streams, into rivers in the bottom. And all of that salt that's coming to the top is being flushed downstream. And so what they found was that there were increases in specific conductance over their 2 decades of study. Usually this increase was at low stream flow. But the biggest changes were in winter, right? You get these big pulses, and you do get pulses that are exceeding these aquatic life criteria. More commonly in the south, in part because as these rivers sort of funnel water downstream, you're just getting more salt being pushed down. And you also might have just more urban development in certain locations in the watershed. And they also found this idea that the sort of background level was increasing, suggesting that we have this sort of like legacy salt polluting groundwater, which is then feeding the rivers. And so this was a sort of a really, I think, amazing amount of work that went into really showing the complexity of how salt is transported, through rivers, in groundwater, and being kind of flushed downstream. So just to conclude, there's a lot of fresh water in the United States. This is a country that is replete with fresh water, especially in the Midwest and Northeast. And kind of take that for granted. And we're at a point where we're really gaining I think a pretty solid understanding of the link between road salt and freshwater salinity. That's been clearly shown. However, there's still a need for more monitoring. There's some locations that are really well monitored, but there's still a lot of types of systems that we don't have a good grasp on. So we need to continue monitoring. Some of our modeling is great for picking where we should be doing that. And I think the next phase that we'll be focused on is really understanding how, as we implement some of these best management practices, as we actually start to decrease our salt use, when does that switch in management practices show up in our lakes and rivers? And so how can we link best management practices to restoration? So I'm going to end there, and just a plug for the rest of the talks this week. Some really great topics coming up Tuesday through Friday. So I hope you tune in to all of them. And I'll stop there for some questions.
Awesome. Thank you so much, Hillary. That was great, as always. I'm definitely going to do some follow up and see about borrowing slash stealing some of your slides and graphics down the road. But I want to jump to questions that have come in here right away. So Ashley asked, is there a time of year slash how often should chloride levels be collected?
Yeah, that's a great question. It definitely depends on the type of system you're monitoring. So for instance, in lakes, I think it doesn't have to be as often. The bigger the lake, the more that water is going to mix. Taking measurements in the fall is often a good time of just seeing like overall concentrations. But the challenge with lakes is that often in the winter, the saline water comes in and goes to the bottom. And so we often take measurements at the surface. And it's also important to think about where you're taking it in the water column. And sampling at the bottom of the lake is just harder than sampling at the surface. But in rivers, it's challenging because you want to be able to capture those peaks as well. And so it's really useful to try and go out when you think it's going to peak. So like, did you just have a big storm? Was there a lot of road salt put down? Can you go out? Like, for instance, in Madison, it would be today. Could you go today and sample some stream water to just try and capture that range? And then, of course, if you could just take samples in the summer to get those sort of like long-term increases.
Awesome. And I did just put into the chat a link to the Isaac Walton Salt Watch page. So the Isaac Walton League supports citizen monitoring across the country. They will mail you or your organization free test strips. So you can go out, like Hillary said, kind of get a sample in the fall, kind of a baseline value, and then trying to get out and hit those peaks when we're having the pulses of chloride. I'm also going to put in a link to the Starkweather Creek monitoring program, which is on the east side of Madison. Whether you're in the Madison area or not, I think there's a lot of incredible data there to kind of take a look at some of the patterns that Hillary was talking at and dive in a little bit more. So I'll jump though to our next question here from Laura. How does a city's use of brine before a snow event affect the salt used?
Yeah, so there's been a lot of talk of switching to brine, and so the brine is the same, like it's the same type of salt that we put down normally. It's sodium chloride. So it is salt. It will do the same thing as all salt, which is wash off. The nice thing about brine though is that the cities and places using brine are just able to use a lot less. So if you think about how much brine they'd be putting down versus how much sort of solid rock salt they'd be putting down, it often is just it's a much smaller volume. And so in the end, it would just be a much smaller volume that's washing off. So overall, the switch to brine is just really helpful because people that have switched to brine, their salt use decreases by a lot. But ultimately, it's ending up in the same place.
And I just added in a link to our page on brine. So I wanted to reiterate one thing that Hillary said is brine is the salt, the same rock salt that we're putting down, is just mixed in with water. One of the reasons why brine really reduces total salt is it prevents the bond from forming. So it's called anti-icing to put that down before the storm, kind of like oiling your skillet before you cook. You get a better scrape, more material comes off. Brine can be used in other ways, and you can also mix in some other components, some sugars and other chlorides with the brine to help it work at colder temperatures and different conditions. So there's a lot of science and a lot of ongoing research into utilizing brine, but in general, it really is dropping total salt use. So I'm going to jump back here to next question. Robert has asked, what is worse for the environment, applying salt to roads or applying sand to roads?
Yeah, so that answer can be context dependent. I think generally the answer is salt is is worse in many locations. One, because we're just using a lot more of it. And in a lot of locations, they're sort of naturally sandy. So the amount of sand that we're adding is not like well beyond what sort of naturally occurs. That said, there's definitely locations where too much sand is a problem. For instance, was sort of some problems in like the Lake Tahoe area where Lake Tahoe is super clear, and there was concern that some of the salt sand they were adding on roads was just making the lake more turbid, so less clear. That's not a problem in many locations because, again, some places are just like, naturally sandier. So it's good to just think about kind of like where the location is, where that sand and salt is going. Is it washing directly into a river? Is it washing into a storm sewer that's then going to the water treatment plant? Someone at the sewage district might have a different answer for you in terms of like, is sand bad for the sewer system versus, is it bad to directly wash into your local river?
It's like in the Madison area, right? Like we do not have a combined sewer system. So all the sand, if it gets to the gutter, it's going to go out into streams, potentially detention pond or basin. But the city works hard to then sweep up all that sand in the spring. So it's not going to any of those places. And despite that, I think they also still go in and have to suck a lot of sand out of like stormwater ponds. So sand can be a mess because it sticks around, right? We see that it's been put down, whereas the salt disappears, right? But it's not disappearing, it's flowing into that water. Sorry, Hillary, I can't resist.
No, that's
we've
super
got we've got a few more questions coming in here though. So Travis has said the most difficult question: how do we convince the public that it's better to have a little snow on roads than roads covered in salt? Because people have gotten used to our roads being bare pavement.
Yeah, it's definitely, a lot of it's expectation. And so we get this all the time where it's like, I went to Finland and there was no salt and everyone was driving on snow-packed roads and it was glorious. And that's because that's what they're used to. So it's really challenging when we're used to bare pavement and all of a sudden we have to deal with a week of snow-packed streets. And so I think the only way to change expectations is to have that experience. And so for instance, here, I keep on bringing up Madison. Here in Madison, we've had a week of like pretty snow-packed streets. And this is the first time a lot of people have experienced that. And so they're going to have, the more days of that you are experiencing, the different conclusions you're going to have on whether or not you think that's okay to have. Like, are you okay with your local neighborhood being snowpacked? People are driving really slowly, safely. I saw lots of people out driving, walking their dogs on these snowpacked streets this morning, and people seemed relatively happy. And so I think it's a lot of having those conversations with people, looking back at your experience, like, how was this last week? What did you think? Like, do you think that we need to be salting everywhere? Were you okay with these small streets being snowpacked and driving slowly? And at the same time, our interstate was bare pavement because we used a lot of salt on it. So, trying to have people come to conclusions about like where that happy medium is, right? Like, we're not saying no salt, we're just saying less salt. And so where is that kind of middle ground?
And I will put in there one more plug that when we get to those super, super cold temps like we had last week, putting salt on at that point isn't really doing any good because the salt's not going to melt. So there are decisions along the way, and sometimes people are happy with and unhappy. Even the city streets department, I would say, is not really happy with the state of the roads last week, but by that point, their hands were pretty tied. All right, so we got Brandon here with a couple questions about, which is a perfect lead in to this discussion. Are city administrators struggling with balancing public safety with the salt on roads versus environmental protection? And also I had kind of a follow-up to that. Besides Wisconsin, are other states or regions taking a lead on chloride reduction?
Yeah, Allison, you might be able to speak to like the other states question. I think this is a conversation in a lot of areas, especially areas that have a lot of fresh water, right? We're not anywhere near the ocean. And so we have very different concerns than maybe still like a city that's literally their stormwater is washing into the ocean. But, in terms of, I think it would be an incredibly challenging to be a city administrator during these events, especially that in those jobs you only usually hear the negative comments. So I will say, if you are very happy with the city's decisions and their snow plowing, give them a positive compliment. So it'd probably be nice to hear.
Brian would love that. Yeah, so, and Brandon, I would say that there are a number of states, Wisconsin is definitely not in the lead. I would say our neighbors, to the west, Minnesota, and they've passed a statewide chloride management plan, and they've done a lot, kind of, it's the pollution control agency, so kind of Wisconsin's version of, or part of Wisconsin's DNR, has done a lot of work with training programs and instituting those programs and different like model legislation, ordinances for municipalities, etc. And there are other states that are working on this work as well. New Hampshire has liability protection that's been on the books for 10 years that covers contractors right now, but they're kind of growing that training program to also support municipalities and counties and their state DOT. Other states that come to mind right away doing good work, Ohio has done a number of things. There's good work in Michigan. So there are a number of states. You're hearing me mention like, Great Lakes states kind of going out to the east, the Northeast, that have been having conversations, trying to sort out what are the different ways that we tackle this is a multifaceted problem, right? And there are different stakeholders that need to be addressed and supported as we move to adopt best practices in winter maintenance and also communicate all of that out to the broader public. All right, Kelly has a question. I just want to note, we are a little over time here right now. Hillary, if you're okay, I'll keep pitching a couple more questions your way. But thank you, everybody. If you have to, pop off, we totally get it and hope to see you tomorrow or later this week. So with that, Kelly asked, or maybe this is a comment, phosphorus sorbed to sand is another issue with using sand. I don't know, Hillary, if you want to speak to that at all.
Yeah, I can't see too much. There's certainly some of the sand mixtures we use are, 95%, 5% salt. So we are using salt with that sand. And so yes, there can still be salts. Generally it would just be that like a much lower quantity than us just putting down, pure rock salt. So I think it's still, we're still moving the needle, which is important.
Mm-hmm. Yeah, and it kind of goes back to the questions too. Sand does not melt snow and ice, right? It can give us some traction. Is that the level of service that we feel good about on a given road, right? And last week when it was really icy and salt was not melting, putting some sand down could buy us at least, some traction and slightly improved conditions. All right, so last comment that I see here is from Jason saying neighborhood street should just be assumed to have some snow on with management as needed. So I'm just gonna double check. Yeah. That I don't see any questions that have come in through Gmail. So I think we're good there. Hillary, thanks again so much for your time. I don't know if you got my email. I shared a few little tidbits about, working with you, how incredible it's been these last several years. Also the picture of your socks. You have a good sense of humor. I gave you credit for these. I don't know if it's going to show up with my blurred background here. The keep freshwater fresh, shovel more, salt less sign. So awesome, Hillary's work. We got stickers of that. If you're in the area. If you're not and you want, well, I think I emailed those out to everybody. So let me know. We're just so excited about, I think Hillary and I are both really passionate about this work and eager to continue to grow this movement and conversations around smart salting and best practices. So thanks again for joining in today and hope to see you later this week. And please do share the link to this webinar will be good for perpetuity. So send more folks to Hillary's YouTube. Thanks so much. Any final comments, Hillary?
No, thanks. Look forward to the rest of the week.
All right. Bye-bye.
Yeah.